Hello everyone, welcome back to the City Guard Dev Diaries series. So this is episode 2 and a bit of an impromptu episode. I didn't really know what to do for this episode, but it's been a while, so I thought I might as well record another one. And what today's video is going to be on is actually just how I started off my game, because I mean, obviously there's still a lot that I have to work on my game. I mean, you know, as you can see right here, there's really not a lot to my game at the moment. I don't even have like a terrain or anything like that. At least that's how my games look. They never look very complete, but there is a lot of code that is going on behind the scenes. And so I thought I'd take the opportunity to just talk about how I actually start developing a game, because it's quite interesting. It's something that me and my friend talk about a little bit. I have a mate who's also into game development, and he usually starts out by blocking out the level to begin with. So he actually starts at a level design stage, and I imagine that's what most people start at as well. I think it's maybe a little bit unusual to start off with implementing the logic, but it's generally what I prefer to do. And so that's why you might be wondering, okay, Dominic, why are you creating this Dev Diaries series when the game looks like I started it yesterday? But the fact is, I have been working on it now for many months, and the only reason why it looks so empty is because I don't focus on level design straight away. I focus more on logic, so that's why when I go in to actually play my game, you know, obviously there's a bit more in the way of actual implementation. So, you know, there's some stuff going on up the top there. Not that all of that's implemented, but, you know, parts of it are implemented. And, you know, the mini map in the top right, and obviously the movement of characters. But yeah, so I want to talk about where I actually start game development. And the first thing that I usually do, the first thing that I did when I was implementing the City Guard, was basic camera movement. To me, it just seems like the logical first step. I think if you're a bit more focused on the technical side of implementing games, then maybe you'll be a little bit more like me. You want to start off on some of the actual like logic and programming. And maybe if you're a bit more creative like my mate is, then maybe that's when you'd sort of go down the sort of blocking out the actual design of the level and stuff like that before doing any of the actual implementation. So how does my camera system work in the City Guard? Well, the main script that drives the camera is actually sitting on the camera itself, of course, which is the this main camera game object down here. You'll notice that I have a camera dolly as a parent game object, and the reason for that being that, as you can see from the different sort of like rotations of the game objects, you can see that the dolly doesn't have any rotation applied to it, whereas the main camera is rotated down at a 55-degree angle. And the reason for that being that when we actually move the camera around, if you sort of press W and you tell the camera to go forward, then of course if you're acting on the main camera's transform, it's just going to go forward down into the ground, whereas that's not what we really want. We want it to just move forwards on, say, the Y plane or whatever, whichever one it is. I kind of forget nowadays. It is the Z plane. Yeah, so if you want the camera to actually move along the Z plane, then of course it's a lot easier just to have this camera dolly where you can use the transform of the camera dolly as movement and then use the main camera for other things instead. So on the main camera though, you'll see that I have a camera controller script. It's not a very complicated script, but it does have quite a few different methods in it just for performing different operations on the camera itself. And you can see that when I do programming, I generally try to make interfaces for most of the classes that I create. Now this is not essential by any means, this is more just a personal preference. Some programmers might look at this and think that that's really unnecessary, but for me I really like to create interfaces for most of the classes that I create. But the reason why I think using interfaces is good is, well, of course, their actual purpose. I mean, you know, their purpose is to provide a sort of general interface which people can then interact with rather than interacting with your class directly. And should you want to create a new script, a new sort of camera controller, and replace the old one, then of course it can still follow that same interface. None of the code which makes use of that camera instance needs to necessarily change because they're calling the same methods, but you might have implemented it in a slightly more optimal way. So generally I find following this sort of standard practice of using interfaces really helpful. And my general coding convention is private before public, and of course if I had any protected properties they'd be within here. I also have constants and events up the top. Then I have properties, so you'll see that I have private constants, but then I have sort of public events here. But then when we go to the properties section, you'll see that I have private followed by public, and again if I had any protected they would have sat in the middle here. And so that's generally how I lay out things. And then of course I have the methods, and then of course you'll find protected above most of the public methods. But of course it also kind of depends on other things as well. I generally don't put a visibility for built-in Unity methods, so late update is a built-in Unity method, whereas this override on disable, I'm doing something slightly special here. So I'm actually overriding the on disable and on disable methods which are provided by this CG monobase. So I also have a sort of common base class which most of my scripts inherit from, and it's just this CG monobase here. It provides other functionality, but I'll go into that another day. For now I just want to talk about the actual camera movement itself. So the camera movement is fairly basic. As I say, the camera controller actually exposes methods for moving the camera, so you can move it horizontally, you can move it vertically, you can rotate it, you can tell it to look at a specific point. Oh, actually, sorry, that looking at point actually returns the point at which it's looking at, sorry. But it just has a bunch of useful methods which you can use to control the camera. So that's essentially what the camera controller is for, but then you need something to actually call those methods, and that is where this global sort of events object comes into play. So I try to separate out the actual movement logic with the logic to determine when to move and stuff like that. So I generally separate out actual sort of like input capture from the logic of actually moving. I think it's a very good idea to sort of separate out some of the logic. I'm not going to talk too much about, you know, best practices and different programming sort of design patterns and stuff like that, but generally you want to follow that kind of principle, I'd say. So if we go into the keyboard script here, you can see that I've created this other script which is for capturing most keyboard interactions from the user. So it's quite simple really, you know, every frame we essentially check to see, okay, is the escape key pressed down, is the return key pressed down, and we also get the different sort of axes that you might be used to if you've used Unity before. So we get the rotation, the horizontal axis, the vertical. The strafe is something that I've added. I don't think it's actually built into Unity by default, but that's essentially the E and Q keys. That's what's being used as rotation in my game, as with most games. And you might notice that I've got a custom function here, so I'm actually using my own method for getting input rather than using the sort of standard Unity input get access. And the reason for that is because I needed to provide my own sort of smoothing function. And you can read the comment here as to why I've done it this way. Essentially, I'm using timescale to pause my game, and get access doesn't work very well with timescale. Like, I don't know whether it's a Unity bug or whether it's meant to be like that. I don't think it's meant to be like that, because it doesn't really seem right in my opinion. So I basically had to implement a fix where I'm using get access raw as a replacement of get access, but of course I still wanted that smoothing that get access provides, and so I'm having to use a custom sort of smoothing function, which you can see down here, and it takes into account stuff like, you know, the sensitivity and the dead sort of variables that are built into Unity anyway. You can also see here that I have sort of like a special way of invoking functions as well. Of course, this is all stuff that I've just built up over time. This is stuff that I've just implemented. I needed a sort of custom sort of invoker class to invoke the different events. And I'll probably go into that in more detail in the future as well. But if you read the description there, you can see that the bubble invoker cycles through all invocation methods within a delegate and calls them one by one, and that's what the bubble thing is all about. It's basically bubbling down the chain of different methods which it's meant to be calling. However, the difference is that it also passes in a next output parameter, so that any of the methods can then stop that bubbling effect. So you'd expect the methods to register in a certain order, and that's how it works. And the way it works is through this bridges game object. I'll go into this in more detail in the future as well, but essentially once we have listened to input from, say, this keyboard class, it raises events. Now the camera isn't actually listening to this event, because my logic was that I don't want the camera to know about input at all. And likewise, the keyboard logic, you know, the thing that's actually listening to key presses, doesn't need to know about the camera. You know, why would it know about the camera? They're two completely different things, you know. The keyboard is one thing, the camera's another thing. So this bridges is essentially something that I've sort of thought up myself, but maybe it's a standard sort of software pattern. It's nothing that I've really read up about. It's something that I just sort of implemented myself. And the reason why it's called a bridge is because it bridges two separate parts of the game. So if I find the relevant script here, you'll see somewhere that we have a script to move. Okay, here it is. So you can see that I have this keyboard to move camera class, and you can see it has a simple register method which is exposed from this iBridge interface. So you can see that this is a sort of bridge class, as I've sort of called it. And you can see that it listens to events which are raised from the keyboard, and then it also references the actual camera controller, so it gets the actual main camera in the scene and then gets the iCamera component. So you can see there we're using the interface as well. So should we replace it with another component, then it will work exactly the same way, which is great. And then you can see that when we are clicking the E and Q key, we know that we need to rotate the camera. So we simply say rotate camera, and we're referencing the actual camera controller, and we're calling the rotate method. And it's as simple as that, really. Now you can see that I don't actually use the bubble invoker for this because no output parameter is being passed in. So it works slightly differently for sort of the standard inputs. I guess you could say it's a bit of an inconsistency, but not really. I mean, it's just something I haven't really got around to implementing yet. Whether I really need the bubble invoker or not, it kind of depends on if anything else will require keyboard input in the future. At the moment, I've sort of also implemented a sort of blocking feature, so that if you do have a form open, then that will generally block the keyboard so that you can't use it until the form disappears again. So there's other ways of doing it as well. And of course, the order in which methods get called depends on the order of the scripts within this list. So if two scripts within this list do listen to the same event from, say, the mouse class, the mouse event class, then the click to plot patrol script will receive that event before click to select waypoint, and that way we have a sort of order to it. And so if clicking to plot patrol points took precedence over selecting waypoints, then of course we could stop it from bubbling down any further. But if we're not currently plotting patrol points, then we could allow it to then move on to the next one, to the click to select waypoint script. It's a rather convoluted explanation, but that's how movement essentially works within my game. So we capture keyboard input within this class, and this class is a component within a game object in my scene. We then raise some events which are caught by the bridge class, which I showed you earlier, the keyboard to move camera class. So that actually listens to the events, and then of course that is what actually interacts with the camera controller. And that way the keyboard doesn't need to know anything about the camera, and vice versa. Obviously this bridge knows about both of them, but you can see that bridge classes are just generally very small scripts. They shouldn't contain much logic. They're literally just for binding two different classes together that otherwise don't need to know about each other. It supports decoupling. If anyone out there who's watching is a software engineer, you'll probably know what the term decoupling means. It's basically just removing unnecessary dependencies which sort of hold back your software from being very maintainable. If you have decoupled code that doesn't sort of rely on each other much, then of course you sort of have that modularity to swap components in and out. And again, it kind of comes back to using classes again to maybe re-implement a certain class, and then you just swap it out from one to the other, and it shouldn't really affect anything if you've done it correctly. So it's about minimizing those sort of knock-on effects when you have to go back and refactor code. And that's one of the big things about software engineering. You never write code perfectly first time round. You always need to go back and refactor. That's just a reality. Code always needs to be revised over time and improved. Certainly if it's a big sort of part of your software, if it's playing a crucial role within your software and it's maybe got a lot of code behind it, it's undoubtedly going to change in time, or you may need to replace it entirely. And using interfaces and sort of decoupling the code supports that. So when I started developing the City Guard, I very much wanted to promote sort of separating out classes not having much in the way of dependencies. So I think I've done a pretty good job so far, and that's really where I started with the City Guard. So yeah, I started off by having a few of these event classes. I started off creating a few bridge classes which listened to those events, and then of course acted on any other game object that they needed to within the scene. So in this case it's acting on the main camera controller. So that's really where I started with the City Guard. I started with camera movement, and the camera movement that I implemented is much the same as it is now, 6 months down the line, and it hasn't changed too much. It's improved over time. You can see that it sort of rotates around to the center point that it's looking at, so I took a bit of time just to implement that. Of course, I will come to make some changes to the camera movement once I've implemented a terrain, because you got to think like, okay, is it going to support rolling terrain very well? Seeing as the rotation is sort of based around where you're looking, of course if you have a hill and all of a sudden your camera jumps to another point because it's sort of, you've just gone over a steep hill, then of course it's going to start rotating in a totally different place to where it was a second ago. So there's certainly more I need to do with my camera movement, but for now it definitely fits the purpose. Thanks for listening. I'll see you in the next Dev Diary.